Working in the drone sector, we know that sometimes the naming convention could appear a bit confusing, so it's time for some clarification. The key terms of the sector are three: drone, UAV, and UAS. Let's see together what that really means. Drone is by far the most known between the three and is a very general way to refer to any type of unmanned vehicle, meaning a vehicle without a person on board. An example is the NASA Mars Exploration Rover, launched to explore the Martian surface and geology. An unmanned aerial vehicle, commonly called UAV, is an aircraft that can operate with various degrees of autonomy, either under remote control by the pilot or autonomously with the autopilot. And finally, UAS, or Unmanned Aerial System, is the term that identifies the entire operating system, including the UAV and associated support equipment, data links, telemetry, necessary for an operation. In other words, everything that you need to have to fly a pre-planned mission. The domain of application of drone technologies are numerous, starting with the construction and infrastructure sector, the leading application field in the market. In fact, UAVs possess many benefits for engineers and architects. Digitalization and smart drone application can ensure a continuous project management during each phase. Drones make data collection faster, easier, safer, and cheaper. Our team at RSS Drones use 3D modeling software to map and monitor large workspaces, with also the integration of the 3D models and point clouds with CAD-like softwares. Agriculture is the second leading application sector in the drones market. The use of UAVs, in fact, has a huge added value for the viticulture and agriculture sector, overcoming the challenges associated with climate change and the increase in the extreme weather patterns. Drones technology can help farmers to keep their activities monitored and sustainable, offering crop health monitoring, 3D mapping of the field, land counting, and biomass measure to produce geotagged vegetation index maps. Another important sector for drones is the environmental one, including environmental monitoring and conservation. In fact, drone technology provides quick, easy, and inexpensive insight in the field, leading to a more efficient management of water resources and forests, allowing water and gas leakage detection. The applications in this domain are in continuous growth, and we, for example, use drones to both model hydrometeorological risks and provide maps and immediate disaster response internationally. Another increasingly important sector for drones is the energy sector, especially the renewable one. In fact, wind farms, photovoltaic systems, and other critical infrastructure can be subjected to a detailed drone inspection in the safest and most economical way, before and after the installation, together with maps of the terrain and energy efficiency detection. We are currently implementing our services using thermal and multispectral camera mounted on Microdrones drones. Here we can see the key differences between 3D models created starting with photos taken by the camera mounted on drones and the ones created from LiDAR point cloud. Let's see the difference. The first type of model comes from photogrammetry, a technique that allows an high-resolution reconstruction of the real world, but from a top perspective only. The LiDAR 3D model is point-based, meaning that it's made by millions of points captured by the active sensor that sends laser pulses to the target and measures its position in the space using the reflection time. It allows a perfect 3D reconstruction, especially of dense vegetation, where light pulses penetrate between leaves with branches and trunk